Hi everyone, in this video we are going to talk about static route. Router can learn about remote networks in two different ways. Firstly, manual method. Here, remote networks are manually entered into the routing table using static routes by administrator, whereas the dynamic routing involves remote networks are automatically learned using dynamic routing protocols. Why do we need static route? Static routing provides some advantages over dynamic routing. So what they are, firstly, static routes are not advertised over the network, resulting in better security. Secondly, router do not share static routes with each other, thus reducing CPU or RAM overhead and saving bandwidth. There are certain disadvantages when you're using static routes. Firstly, initial configuration and maintenance is time consuming. Configuration is error prone, especially in large network. Administrator intervention is required to maintain changing the routing information, does not scale well with growing networks. Maintenance becomes cumbersome, requires complete knowledge of the whole network for proper implementation. Static routing has three primary uses, nothing but the advantages. That is, it is useful if you're configuring the routes in smaller network. Secondly, providing ease of routing table maintenance in smaller network. But when you're using it in larger network, please keep in mind that this will be a cumbersome process. So you should be using this for a smaller network only because you will have to add the routes manually. Okay, so that's all about a brief introduction about static routes. Let's get started with the lab and configure static routes. We have taken two routers connected via network address 10.1.1.0, where we can assign 1.1 to this port here and 1.2 on this port for this router 5. We have loopback address 0 connected to each of this router. So for the router 4, the loopback address is 30.1.1.1, and for the router 5, the loopback address is 20.1.1.1 with /24 subnet mask. First, let's go ahead and configure the IP address for each of these routers and turn on its interface. So let's go to router 4. Interface over here is first Ethernet 0/1, IP address 10.1.1.1 with /24 subnet mask. And let's turn on this port. Let's go to router 5 and configure the IP address. Interface first Ethernet 0/1. That's what we see here. The IP address that's assigned to this is 10.1.1.2 with /24. And say no shut. And since both the interface are now no shut, you can see that this interface are turned on. Now you can try to see if you can ping from this router 4 to router 5, and you should be able to ping it. So from router 4, I'm pinging this IP address over here, 10.1.1.2, and that worked. However, you have loopback address here, which we still have not configured it. Let's configure the loopback address for each of these routers. Let's go to router 4. Configure interface loopback address loopback 0. here you don't need to give no shut command because the loopback address will be by default um, in no shut status. Okay, it will automatically get its status changed to up. You can see that line protocol on interface loopback 0 has changed status to up, and that way you do not need to give the command no shut. And even if you give it, it doesn't make any difference. Okay, so let's assign the IP address. So 10 IP address 10.10. Oh, sorry, we got IP address 30.1.1.1 with /24 subnet mask and just exit out. Similarly, let's configure the loopback address on this router 5. Interface loopback address, loopback 0, IP address 20.1.1.1 with /24 subnet mask. Okay, now we have configured the IP address for each of the routers and the respective loopback address. Let's verify using the command show IP interface brief. You can see the loopback address is configured and the port. Similarly, let's verify on this router here, show IP interface brief. You can see that loopback is configured here as well with the fast Ethernet IP address. Okay, so now here, if you want to ping from router 4 to loopback address, it's not going to work. If you want to verify, let's see if you can ping the loopback address, and you can see the packets drop 20.1.1.1. It's timing out. You can see that the packets have dropped. The reason is because on the routing table, it does not have this loopback address. All it knows is just the directly connected network. It doesn't know anything about this loopback address here. So you need to make sure this router learns about this IP address over here with the help of configuration of static route, where you are going to tell this router 4 about this IP address to be present in its routing table. So if you want to see the routing table show IP route, you can only see the directly connected IP address. It doesn't have this IP address over here. You can't see 20.1. You can only see 10.1 and 30.1, the two directly connected networks. But you cannot see this. So let's configure IP static routes for each of this router. IP route. So this is the destination network. So 20.1.1.0 with subnet mask for the destination network and the next hop address. So for this router 4, the next hop is this interface over here. So it needs to be 10.1.1.2. Similarly, let's configure static route on router 5. IP route. So for the router 5, the destination is this loopback address. 30.1.1.0 network, okay? It's going to be destination network address and the subnet mask of the destination. So that's going to be 255.255.255.0. next hop address. So for this router 5 to reach this loopback address, this port over here is your next hop. Okay, so the IP address on that port is 10.1.1.1. You can just exit out. Let's check the routing table now to see if it has learned the static IP address that we just configured. Show IP route. There you go. The two networks are still there, which are directly connected. And it has learned the destination loopback address with the distance metric of 1 via next hop. This is your next hop address for this router. And for this router, your next hop is going to be this IP address. Let's verify. Show IP route. You can see that the two directly connected networks are still there. And it has the static IP address that we just configured for this loopback address with a distance metric 1 connected via next hop address, which is 10.1.1.1. Okay, so now since we have configured the static routes, let's see if your router 4 can ping the loopback address now. Ping 20.1.1.1. There you go. You can see that it's pinging. And similarly, from router 5, we will ping the loopback address, which is on this router 4. So ping 30.1.1.1. And there you can see that the success rate is 100% with 0 packet loss. So this completes the lab for static route. I hope that this video has been helpful to you all. See you in the next video.